Welcome to The Debate. The distributed ledger technology landscape, it's really undergoing a critical transformation. We're seeing this shift, moving away from maybe consumer-facing speculation towards, well, concrete, large-scale enterprise and even governmental adoption. And this shift, it really forces a confrontation with foundational architecture.
Mm-hmm. And that confrontation, it really centers on performance and trust, doesn't it? We're essentially asking a pretty fundamental question here. Given that institutions need serious speed, stability, and control, are these non-blockchain DLT architectures, and we're talking specifically about things like the Hashgraph model, are they actually destined to, win the race for enterprise adoption over the established layer 1 blockchains we already know?
Right. And I'm going to argue that yes, the architectural superiority, which you can prove through, well, verifiable performance metrics like predictable finality, fixed, low costs, that makes technologies like Hashgraph pretty much the inevitable choice for large-scale institutional integration.
Okay, and I'll be defending the long-term strategic viability of those established layer 1 blockchain architectures. Because while their raw speed might differ, and we can talk about that, their foundational advantages, things like ecosystem depth, true decentralization, and frankly proven resilience, they offer an intrinsic long-term network value that, well, these DAGs often seem to sacrifice just for raw throughput.
Look, my position really stands from the reality of running mission-critical systems. When we move beyond just, token swaps to high-volume compliant applications, think about secure supply chain tracking or large-scale AI integrity validation, or maybe the future rails for central bank digital currency, CBDC settlement, performance is simply non-negotiable. Traditional blockchains, they inherently struggle here, mainly because of probabilistic finality and those variable fees. The Hedera Hashgraph, because it uses its Directed Acyclic Graph or DAG consensus, it delivers what enterprises actually require. You get finality in seconds, and crucially, fixed low transaction costs. They're cited precisely at, $0.0001? I mean, this architecture is designed for scale and stability. And you just have to look at the data points. Google is running a governing node. IBM is leveraging Hedera for secure asset tracking. EQT Lab uses it for AI integrity verification, and they need predictable costs to log potentially billions of data points. So this level of institutional buy-in, it's a pretty clear indicator of where the enterprise market is shifting its strategic investment.
Okay. I see the point on performance metrics. They are indeed striking. But, they often mask a really crucial architectural trade-off, don't they? Many of these non-blockchain alternatives, well, they achieve those impressive speeds by fundamentally compromising on the core ideas of decentralization and open interoperability. They essentially substitute cryptographic trust with, well, corporate trust. Established layer 1 blockchains, even with their, let's be honest, inherent scaling challenges, which, by the way, are being actively addressed, they benefit from, decades of accumulated network effects and a vast standardized developer ecosystem. The industry standards are actually being built here. You've got the Token Taxonomy Framework, the TTF, which gives us a standardized meta model for digital assets across different sectors, and it's rooted in the architecture of L1 tokenization. We see innovation scaling up the stack. Look at Algorand being used for scientific data integrity with LabTrace, or the entire Ethereum ecosystem utilizing sophisticated Layer 2s and even Layer 3 solutions like Orbs network or those consensus ZK rollups. They're doing that specifically to get enterprise performance and privacy without just ditching the decentralized foundation. We don't necessarily have to abandon the most resilient foundation simply to gain speed.
Okay, let's dive right into that issue then. Stability versus decentralization. Because for the enterprise, one is just far more valuable than the other. When you're operating something like a wholesale CBDC bond trading MVP, which, as the material notes, is powered by Hedera, volatile transaction costs are simply an unacceptable operational risk. It's a structural reality of public proof-of-stake L1s, right? Transaction costs fluctuate based on network load, token value. How do you budget for margin calculations or integrate with your ERP systems when your foundational cost structure is a variable? You can't.
That's definitely a strong point, but have you thought about the nature of control that comes with that stability? You're describing a preference for architectural certainty, which, yeah, I agree, institutions seek that. However, that stability often comes at a governance cost. Hashgraph's entire operation is overseen by this governing council, made up of these very large entities. You mentioned Google, IBM. This structure, okay, it provides legal clarity, cost stability, yes, but doesn't it fundamentally compromise the trustlessness principle, the very thing that made DLT revolutionary in the first place? When regulated enterprises truly demand a permissioned, highly controlled environment, what do they often opt for? They go for purpose-built permissioned blockchains that still maintain that audited linear chain structure. Look at the DTC app chain or PolyMesh for regulated real-world assets, or systems built on Hyperledger fabric like TradeWaltz. These solutions prioritize the chain structure, which arguably is often easier for regulators to audit than a DAG, along with explicit permissioning. So the choice isn't always L1 versus DAG, is it? It's often between an open L1 or a closed traditional blockchain. The market is showing that this kind of brand trust governance, which is basically what the Hedera Council provides, is acceptable to some large corporations, sure. But it's a strategic risk they're accepting in place of genuine cryptographic decentralization.
Okay. Yeah, I see where you're coming from on that, but maybe look at it this way. That framing suggests the governing council is somehow a weakness, when actually, for regulated enterprise, it's the fundamental strength. This isn't really about trusting the brand name Google. It's about trusting the predictability of the governance itself. A decentralized community of anonymous validators is just, well, it's insufficient when you need legal clarity across multinational operations. The cost of potential stagnation or the uncertainty inherent in some open governance models, that far outweighs the theoretical purity of perfect decentralization for these players. Furthermore, let's dissect this idea of adoption. Are Google and IBM simply managing risk, as you put it, by joining a council? Or are they strategically endorsing a foundation that actually solves their latency and cost problems? I think the evidence points strongly to the latter.
Google Cloud offering Hedera services, that signals a deep operational integration. It validates the underlying DAG architecture as fit for institutional purpose in a way that remains frankly challenging for public L1s still struggling to achieve consistent high throughput.
Yeah, I'm sorry. I don't quite buy that argument entirely. Reliance on existing network effects isn't insufficient. It's often the bedrock of longevity and resilience. While you focus on the governing council providing, quote, necessary clarity, what happens when those, dozen or so entities have conflicting strategic mandates down the line? Open source communities, especially the ones around Ethereum, are vast. They're resilient, and they are inherently decentralized in their development paths. That diversity actually makes them more immune to the political risks or capture that could affect a single governing body. And the ecosystem depth built around L1s, it's just unparalleled. It's not just about developers. It's the infrastructure that bridges the digital and physical worlds. Look at Consensus using its L1 foundation. They rolled out the MetaMask card. That lets users spend crypto directly in the real world. That's seamless integration into everyday payments.
And the token taxonomy framework, the TTF, it's not just some abstract standard. It's a global, implementation-neutral blueprint for digital assets. It was forged by industry players precisely to ensure interoperability across regulated markets, supply chains, financial services. Can a specialized DAG architecture really boast that same breadth of standardized integration across every possible use case? I'm skeptical.
Okay, interesting. Though I think I'd frame that a bit differently. That broad ecosystem, while it is vast, yes, it often comes with legacy structural baggage. And that baggage can make rapid, globally consistent regulatory alignment incredibly difficult. I mean, while the TTF attempts to be implementation neutral, the reality of global regulation forces specificity, doesn't it?
Mm-hmm.
And this brings us neatly to real-world asset tokenization, RWA. This is where compliance becomes the absolute bottleneck. We even see the complexity on Ethereum itself, with standards like ERC 728, the next era standard. Its whole purpose is to try and separate the asset data from jurisdiction-specific rules. The very existence of that kind of fragmentation kind of proves that the generalized L1 architecture wasn't inherently built to handle the required compliance overhead on a global scale, right?
But where does fundamental permissionless innovation actually happen? It often begins on the open L1s, doesn't it? Which then informs the development of maybe more specialized DLTs later. While complex compliance is indeed necessary, and yes, it might require specialized solutions, the most transformative financial innovation often comes from those open L1s that fundamentally challenge traditional finance. Take the example of folks finance, pioneering tokenized precious metals, gold and silver, as collateral right there in permissionless DeFi markets. They let users borrow against these physical assets without KYC checks, based simply on the cryptographic proof of ownership. That kind of breakthrough happens because of the open programmable nature of the Layer 1 foundation. It allows for genuine financial engineering that, let's face it, traditional finance just can't replicate in terms of speed or openness. We also see organizations like Ajara using L1 ecosystems, specifically the XRPL in their case, for tokenizing government bonds in emerging markets. These solutions are empowering innovators to solve real-world financial inclusion problems using the proven resilience and often low transaction costs of an established L1 ecosystem.
I absolutely acknowledge the foundational role of L1s in sparking that initial innovation, sure. But that innovation often seems to sacrifice compliance for speed, especially early on, when the conversation shifts from raw innovation to large-scale institutional integration, especially across regulated financial services. Well, specialization tends to be preferred. Look at PolyMesh, which is purpose-built as a permissioned blockchain, specifically for RWA compliance. It's actively shaping regulated digital asset trading. You see evidence like the Busan Digital Asset Nexus initiative. The market trend towards specialized DLT architecture, whether it's a DAG like Hedera or a purpose-built permission chain like PolyMesh, it strongly suggests that the standard public L1 structure is maybe too volatile or perhaps too generalized to meet those stringent institutional demands where regulatory adherence is absolutely paramount. When organizations have to comply with really strict regulatory frameworks like MiCAR in Europe, they naturally gravitate towards architectures that provide definitive stability in predefined governance, which the DAG architecture arguably uniquely offers in a high-throughput public setting.
But that market fracturing you describe is precisely what the standardization efforts born from L1s are designed to manage over time. The core Layer 1 protocols provide the resilient, open foundation that's necessary for truly global, decentralized markets. They offer the security and the network effects to underpin massive initiatives. Everything from, disaster aid disbursements by Mercy Corps in Kenya using smart contracts on established platforms, to large financial players building institutional solutions that absolutely rely on proven L1 security models. We're not talking about abandoning compliance here. We're talking about building compliant solutions on top of what is arguably the most resilient, auditable, and openly developed infrastructure available. The Layer 1 protocols and their enhanced L2 and L3 layers, they represent the long-term resilient path toward a truly global, decentralized, yet functional digital economy.
Well, ultimately, I believe enterprise-level DLT adoption really hinges on predictable, scalable, high-performance architecture, the kind that allows for consistent budgeting and gives legal certainty. The documented buy-in, the strategic infrastructure investment from major institutional players, Google, IBM, into the Hashgraph governing model, it suggests they are prioritizing a structure designed for industrial reliability over perhaps the philosophical ideal of permissionless trust. They seem to be making a very pragmatic choice for throughput and certainty.
And conversely, I'd argue the long-term strategic advantage of traditional Layer 1 blockchain architectures lies precisely in their proven ability to withstand shocks, their deep, self-sustaining ecosystems, those established open standards, and, critically, their continued ability to foster the kind of permissionless financial innovation that genuinely pushes the boundaries of the digital economy. That fundamental strength, the power to democratize and innovate, that's the true long-term value proposition that I believe will ultimately define the infrastructure of the future.
Well, while both architectures clearly drive significant global impact already across finance, supply chain, public services, The question of which foundational DLT technology will ultimately anchor the future of regulated enterprise and institutional use. Yeah, that remains a powerful and, I think, still very open strategic discussion. It certainly prompts deeper exploration of these underlying trade-offs in performance, trust, and governance.